Hi, I'm Nandhini, hosting a assistant professor in the SMS College of Engineering at the Department of Computer Science and Technology. Today, we are going to see a topic on scalar types in data analytics with R. Let's see what is a scalar types. Scalar types, for example, we can take a contact of the person with the help of his name. Next one is the maximum temperature of a registration given for a town. In a people, in a home, in a town, in a city, what is the temperature that has been given? Next one is the weight and height and the gender. A person's weight, his height, and his gender together without the information on how good their company is. For example, there are two larger family scalar types. Let's see what is a quantitative scalar type and a qualitative scalar type. Quantitative scalars are categorized data which are having two types. Which one is a nominal or an ordinal way? What is known as a nominal and what is an ordinal data? Nominal data cannot be ordered according to how a big or a small characteristics is given, but an ordinal data can be get ordered. For example, let's see a tabulation of a data set of our weighted list of contacts with the weight and the height of a given person. For example, in the first column, I have friend is given. Next one is a maximum temperature, his weight, height, gender, and the company's um, conduction of a company about a person has been given. First one for an Andrew. Maximum temperature for him is 25. Height of him is 175, weight of him is 77, and the gender is male, and the company is known as given him a conduction of a good. The data set of a person's weight and height. Next one is Bernhard. His maximum temperature is 31, weight is 110, height is 195. His gender is male, and a company given him is good. Next one is Carolina. His maximum temperature is 15, his weight is 70, his height is 172, his gender is female. Company given as a conduction is a bad. Next one is Denise. His maximum height is 20, weight is 85, maximum temperature is 20, height is 180, his gender is male, and he has given a conduction of good. EB. His maximum temperature is 10, weight is 65, height is 168, his gender is female, and he is given a bad conduction. Next one is a Fred. Its maximum temperature 12, weight is 75, height is 173, gender is male, and the company is good. Next one is an Hygiene. Its temperature is 26, weight is 63, height is 165, gender is female, his conduction is bad. Iron. His temperature is 15, his weight is 55, his height is 158, he is female, and they have given a conduction of bad. Next one is Kevin has given us 30, 95, 190 is male, and given a conduction of bad. This Miguel, his maximum temperature is 12, his weight is 115, his height is 192, his gender is male, and he has given a conduction of good. In this tableau, we are known that each person have been given a conduction with a good or a bad conduction has been given to them because, for example, the name of the contact is expressed on a nominal scale, while the information on how a good the company is can be expressed on an ordinal way because we can define an ordinal of magnitude ranging from a good to bad. Because a good expression having a higher level of fellowship than bad, the notation of magnitude does not exist in the names. For example, there are two types of quantitative data. So one is an absolute ratio and a relative interval. The difference between them is that in absolute scalar there is an absolute zero, while in a relative scalar there is no absolute zero in another scalar. Next one is an example. When the attribute height is zero, it means there is no height. When the attribute height is one, it means there is an height. This is also true for the weight, but for the temperature, when we have a 0 degree Celsius, does not mean there is no temperature. We have to take a weight to consider his twice as much as iron, but we cannot say that the maximum temperature last week is Daniel's hometown was twice that of his e-base. because it is a scalar type. We need to compare the data. This is why we usually use it to change in temperature to characterize how the temperature varied in a given day instead of a given ratio as been calculated here. For example, a weight is expressed in the form of scalar kilograms. We can convert it into any other social value such be assigned to the hyperparameters. Next one is a relative. The weight can be converted to a relative scalar by form instead subtracting a value of 10. The 0 becomes a minus 10 and the new 0 is a older 10. That means that the new 0 does not mean any more that there is no weight. The new 80 kg is no longer twice the 40 kg. Try to figure it out because it has been figured out easily. Next is an ordinal weight. We can define, for instance, level of fattiness because fat when they are larger than 80 kg, nominal when the weight is larger than 65 kg but equal to 80 kg, and thin when the weight is less than or equal to 65 kg. With the classification, we still have the possibility to define group of people such the way less than a fat which consists of a 65 kgs or 80 kgs that have level of fattiness. There was no special reason, but there is a rational ways. Next one is a nominal one. We can classify the previous classification as a fatty nominal one into B, A, and C respectively. With such a classification, it is not possible to have a context according to how far they are because B and A and C do not qualitative anything in a given way. Be attentive. What is known as be attentive? By communicating with the scalar types with the help of that tabulation, we need to have an attentive data intervals of data to get the possible values because the answer will be nothing. It is a kind of key. Its values may eventually express how old the card is, but typically nothing more than that. Next one is called the letters. It could have maintained the same information has been given. Thank you so much for